All right, so we didn't get to cover this in class today, and a couple of questions on your homework might trip you up a little bit, and I wanted to give you guys a few pointers. So the first part, so this is number 60 on the worksheet that I gave you guys for homework. So you didn't have to do number 60, but it's very similar to number 61 and 62 that I did assign. So the first part of it, you're going to know how to do. You're going to be given two amounts of the reactants and being asked to see how much of the solid product you're going to have made. But then the second part is a little bit more tricky. You have to calculate the concentration of each ion remaining in solution after the precipitation is complete. So the first half of the part is figuring out what the equation is. So this is what it looks like. I've already run through this video once and forgot to save it, so I had to white out a few things. But this is what your reaction is going to look like if you make sure that you cross-charge your compounds and then you balance to make sure everything's written correctly. Once you have the reaction, then you can do the two stoichiometry problems to solve for how much product can be made. So I started with the volume and molarity of the silver nitrate. So it said 100 milliliters, but you have to use it in terms of liters because molarity is in terms of liters. So I turned the 100 milliliters into liters, multiplied by the molarity. Then I use the mole ratio between the reactant and the product. And I'm talking about the solid product here, and then use the mole ratio, the molar mass of that solid product to get to grams. And I did the same thing with the other reactant. This is the given volume and the given molarity, mole ratio, molar mass, and this is how much of the solid product it could make. So looking at the two, I can tell then that I can only make the 2.9 grams of silver chloride. And then looking back at this, I can say, okay, if this is how much can be made, that means that my AgNO3 is the limiting reactant. So from this, I can make that conclusion, 2.9 grams of silver chloride can be made, and AgNO3 is limiting. So that concept that AgNO3 is limiting becomes really important. So I'm going to highlight the AgNO3 and point out to you guys that remember, like, this is all going to be reacting and making solid product until one of the two parts runs out. So we found out that AgNO3 is limiting, which means that the silver runs out, which means all of the silver that was in the AgNO3 reacted and turns into a solid. So all of this silver is now found over here in the solid product. So an important part for this then, for the second part of the question, when it's asking about the ions in solution, we're not going to have any silver ion floating around at all because it's all in the solid, okay? And the reason this is because it's the limiting reactant, so it ran out, it all turned into the product. So we're not going to have to calculate any silver floating around in solution because there's no there. Other things we can take note of, the other aqueous product, remember it's aqueous, so really these are floating around in solution. We're going to have calcium and nitrate that didn't take part in the solid whatsoever. So whatever got poured in is still floating around in solution in the same amounts. So those are our spectator ions, calcium and nitrate. Those will be pretty easy to figure out the concentrations of. And then the other ion that we have to concern ourselves with is the chlorine. So if you take a look, in the solid product we do have some chlorine, and it was present in the excess reactant. So because it's not limiting, it was present in excess, which means some of it ended up in the product. However, there's still going to be some floating around in solution, so we're going to have to figure out how much chlorine is left floating around in solution. So the easiest ions to start with are going to be the spectators. So starting out with the calcium ion, what I did was start with the volume and the molarity of the solution that contained the calcium. And then I used the mole ratio within that compound to figure out how much calcium ion I had. So it was a 1-to-1 ratio of calcium chloride to calcium. So this is how many moles of calcium ion I have. And then to find out the concentration, I just have to put that over the total volume. And remember, in the problem it told us we have 100 milliliters of one reactant and 100 milliliters of the other reactant. So combined together, once they get poured together, that total volume is going to become 200 milliliters. So then to find the concentration, we're going to put the moles of the calcium ion over that new total volume of the both reactants added together to get the concentration. So that's the concentration of the calcium ion, and you're going to do something very similar with the other spectator ion. You use the volume containing the volume and molarity of the compound containing that spectator ion, and then use the mole ratio within that compound to figure out the moles of that ion. So here's the moles of the nitrate ion that's floating around. And then once we have that number of moles, we can put that over the total volume to get to the concentration of the nitrate ion. Okay, so the spectator ions are not too difficult. But moving back onto the chlorine, like I explained, we're going to have some chlorine still floating around because it was part of the excess reactant. So the first thing we need to figure out is how much chlorine we started with in the first place. So I'm going to take the given volume of the compound containing chlorine along with the molarity of that compound, and then multiply using the mole ratio of chlorine to that compound to figure out how much chlorine ion I have. Okay, so that ends up being 0.030 moles of chlorine ion, and this is how much I started with. The next thing I have to do is figure out how much I used. And in order to figure out how much I used, I have to first figure out how much of the limiting ion I had. So really the more important ion of the limiting reactant here was the silver, because that's what went into the solid. So I started out with my 100 milliliters of the silver nitrate. It was 0.2 molarity, and then within that silver nitrate it's a 1-to-1 ratio of silver to silver nitrate. So this tells me how many moles of the silver ion I have. So that's important to know, because then I can use the ratio of silver to chlorine in that solid to figure out how much of the chlorine I need to use to react with our limiting reactant here. So if I have this many moles of the limiting ion, I can start with that here, and then I'm going to use that ratio inside that precipitate. It was a 1-to-1 ratio, and that's why I have 1 mole of chlorine to 1 mole of silver. If it had been AgCl2, it would be 2 moles of chlorine to 1 mole of silver. So essentially what this ratio does is tell me how much of the chlorine I use to react with the silver. So anyway, once you do the math out, it becomes 0.020 moles of chlorine used to react with all of the silver. So now that we know how much we used to react with all of the silver, we can take how much we started with, subtract how much we used, and this is how much chlorine remains in solution. So the last part of that's pretty simple. We just put that over the total volume, and you have the molarity of the chlorine still floating around in solution. So I hope that was helpful. I'll go over it in class tomorrow if you guys have any more questions, but I hope that was enough to get you guys through it.